All right, so let's go to our first page of notes, talking about relations and functions. Relation is a set of ordered pairs. So your ordered pairs would be x comma y. X represents some number, y represents some number. So anything that can be written as a set of ordered pairs, that is a relation. So your domain, which is also sometimes known as your input values, would be your x's. So that first value in your ordered pair, that is your domain. Your range, also known as your output, is that second value in your ordered pair, or your y value. So x, input, domain, those all mean the same thing. Y, output, range, those ones all mean the same thing. So every relation consists of a domain and it consists of a range. So now some relations can be categorized a little bit more specifically. They can also be called a function. So a function is a relation in which each domain element is paired with exactly one range element. So what that is, simply put, is your domain cannot repeat. Anybody remember being told that at some point in time? Domain cannot repeat. If it does not repeat, that means it is a function. If you have a domain value that does repeat, then it is not a function. So our notation for that would be the f parenthesis x. Yep. This reads as f of x. That's how we read that notation right there. So the f parentheses x, we read it as f of x. They can change those letters, g of x, y of x, h of x, a of n. They can even change that number inside. So for functions, if you have a graph, you can do a vertical line test to tell if it's a function or not. So let me see here. I'm going to draw a little graph here. So for this graph here, if I draw a vertical line at any part of the graph, it can only hit it once. So if I draw a vertical line there, it will hit it once. It is a function. Over here, hits it once here. Any part of the function, it can only hit once with a vertical line. That means it is a function. For it not to be a function, it would have to hit more than once. Let's see here, I'll draw one of these. So for this example here, and somebody asked me earlier, and it was actually a very good question. If I draw a vertical line right here, how many times does it hit? Once. So people are like, oh, it's a function. But you have to keep in mind, if I draw it over here, though, it's going to hit twice. So it is not a function. So any part of the graph, if it hits more than once, means it's not a function. Does everybody remember vertical line test? So far, that's the stuff we have been taught before, hopefully. The new ones are a one-to-one function and an onto function. So a one-to-one function passes the vertical line test, because that tells you it's a function, but it also passes the horizontal line test, and that's what tells us it's one-to-one. So let's draw a picture here. So let's say I have this graph of a line here. If I go ahead and I do my vertical line test, is it ever going to hit anything more than once? No. So we know it is a function. If I do my horizontal line test, which is a new one, is it going to hit the graph more than once that way? No. So that means this is a one-to-one function. So one-to-one function is just a more specific kind of function. Not every function is going to be one-to-one. So then the other one, and this one's actually kind of difficult to understand sometimes. Onto, an onto function means it uses every single possible range value that the function has. So let's see here. If I draw this parabola here, our range would be this value and then everything less than that. So would it ever use these values up here above the graph? No, so this one is not onto. I think it's easier sometimes to show a bad example first. So that graph is not onto because it's not going to use those range values up above the graph. However, let's say I had kind of like that one I did up above, my little squiggly there. Will that eventually use every single y value? Yeah, because that's going to keep going up, that's going to keep going down. This one is onto. So a function can be just simply a function. It could be one-to-one, it could be onto, or it could also be both. It could be both one-to-one and onto. So just another way we can categorize our functions. So now let's go through our different ways of being able to represent a function and being able to write out the values within that function. So I'm starting here with this little number line. So we've got a closed circle on our -2, open circle on the 0, closed circle on the 1, and then we got that arrow continuing on forever. So that means it just keeps going on forever. Could we be in both shaded areas at the same time? No. So whenever we're going to be dealing with this, we always have to use the word or, because you're either in this shaded part or you're in that shaded part. So let's first write this out in words. So we are greater than or equal to -2. Because it's got that closed circle, so it's got the or equal to, so greater than or equal to. And I said greater than because the shading goes to the right of -2. And where does it stop? Stops at 0. And less than 0. I said and this time because that shading connects those 2 points. So yes, you are both those things at that time. You are greater than -2, but less than 0. Or greater than or equal to 1. Writing it out in words usually takes a long time. So instead of writing things out in words, they came up with these different kinds of notations. Give you a second to finish writing that. All right, so our interval notation, it uses 2 kinds of symbols. It uses parentheses when something is not included. So that would be an open circle. So like, for example, whenever I talk about my 0 there, I would use a parenthesis if I'm doing interval notation, because that value is not included. And then brackets if it is included. And that would be closed circles. So like our -2 is going to have a bracket, our 1 is going to have a bracket, because those values are included since it's got closed circles. So with our interval notation, to describe this first shaded part here, we would do bracket -2, comma 0 with a parenthesis. So that means our shading starts at -2, has a closed circle because of that bracket, ends at 0, but it's an open circle, so it's parenthesis. Or, because we do have that second shaded part there, so or, we go from 1 to infinity, because that's got the arrow on the end. It never actually ends. It just keeps going on forever. And there's always a parenthesis on infinity, because you can't put a little definitive stopping point on infinity. It just goes on forever. So there's our interval notation. Much easier to write, I think, than writing it out in words. All right, our next one, our set builder notation. Set builder notation always starts with a little squiggly and then an X bar. That X bar represents X such that. So basically you're saying, I'm using the letter X. The bar says, here's how I'm going to define it. So X such that. So this first part, again, it goes from -2 to 0. So I'm going to go -2 is less than or equal to X, which is less than 0. Again, we got the or equal to with that -2 because it's a closed circle. And then we don't have the or equal to with the 0 because that was open. Or X is greater than or equal to 1. And then our last kind here, our roster notation. That's just simply listing out all of the answers in your solution set, kind of like the roster for a team. They list out all the different players on that team. We can't do roster notation for this though. Because of those shaded parts, that means it includes every single decimal and fraction in between those numbers. So we can't possibly write all of those down because there's actually an infinite number of numbers in between your integers there. So we can't actually do a roster for this. We will do some in our examples coming up. So those are our 3 kinds: interval, set builder, roster notation. Let's take a look at the next page. So there are 5 ways we can actually write our relations. You can write them as a set of ordered pairs, which again, we'll see some examples down below. You can create a table of values. That is another way to be able to show our relations. You can actually graph them on an x and y axis. It's another way to show our relations. Equations and function rules. And then the 5th one I don't think you really have seen before. Maybe a little bit in 9th grade, but I don't think so, is your mapping diagrams. And I'll show you an example of a mapping diagram. So there we go, 5 ways we can show them. All mean the same thing, relations. Some of the relations can be functions. Some of those functions are one-to-one or onto. So let's take a look at our examples. What we're going to do is we're going to first determine, is it a function or not? If it is a function, we'll see if it's one-to-one or onto. And then we'll determine the domain and the range. That's what we're going to practice today. So the first one, here is an example of your roster form. They have just listed out the ordered pairs. If we look at our domains, which is what we have to look at to determine if it's a function or not, would this one be a function? No, because you've got that value of 2 in your domain that is repeated. So not a function. So for these ones, when you do your domain and range, you're going to write them out as your roster form. You're going to write them out as a list. And your list always needs to go from least to greatest. So our smallest domain value here would be the -4, and then the 1, and then the 2. So -4, 1, 2 is our domain. So same thing with the range. We're going to take our y values and list them from least to greatest. So -3, 1, 5, and 7. And then that one's done. So second one, looking at your domain within our table, is it a function? None of your x values got repeated. So that is a function. So let's determine if it's 1 to 1. So if it's 1 to 1, none of your y values would be repeated. So are these repeated? Yeah, so this is not 1 to 1. And then on to means it uses every single range value. Well, based on our table, the only range values we have are 9, 4, 1, and 0, so it uses all of them. So this one would be onto. It uses all of its range. So domain, let's list out all of those x values, so -3 to 3. You wouldn't want to use interval or set builder notation for this because it's not those values in between. It is purely just -3, -2, -1, 0, 1, 2, 3. Interval says it's the values from -3 to +3, so it would include all the decimals in between, but we don't want that. Our range would simply be 0, 1, 4, and 9. All of your y values there. Even though they are repeated, you don't repeat them when you list out what the range is. So our third one, would this one pass the vertical line test? Yep, it would only hit one of those points once at a time. So this is a function. Right, it would not pass the horizontal, so it's not 1 to 1. And then does it use every single y value possible? No. It doesn't use 2, there's nothing there. It doesn't use 3, 4, 6, 7, or 9, so it's not going to be onto either. So this one is just a function, it's not a more specific one. So this one, for our domain again, we just want to write those x values where those points are. So we got 1, 3, 4, 6, and 8. Because it passes the vertical line test. If I do a vertical line, it would only hit one point at a time. So then our range, we got 1, these ones are at 5, and then 8. So 1, 5, and 8 would be our range there. Number 4, this is what we call mapping. That's our mapping diagram there. With your mapping diagram, they always put the domain first and the range second. So it's really kind of like a table. Just they like to put arrows on there. If we were to write this as a table of values, we would have the point A, D, because it goes from A and it points to D. And then we would have B, D. And then we have C, D, but we would also have C, E. So sometimes it helps to kind of write it out as the table, because then it's a little easier to see. Is this a function? No. Not a function, because your domain repeats. So our domain is everything in that first bubble. So ABC. Range is D and E. So number 5. Yes, it is a function. Because there's 2 arrows coming off of C, so that means it's used twice. So is it 1 to 1? Does it pass the horizontal line test also? Yeah, so this one would be 1 to 1. Is it onto? Does it use all range values? Yeah, it's got arrows that keep going on forever.
You have to write all 3 of those?
Yes. onto. Yep. You won't always have to. Sometimes they'll just simply ask, is it one-to-one? Is it onto? I keep writing it just to get you to keep thinking about it right now. Okay. Domain. So for this one, we are not going to want to use our roster form. We're not going to want to keep writing everything out because you can't. There's an infinite amount of answers here. So I'm going to use my set builder. So it's going to use, because of those arrows, it's going to keep going on forever, it's going to use every single x value in existence. So we're going to say x, this little funky e, and then what I like to call the double R. So the E, the funky E, and the double R stands for is an element of the reals. An element of the reals means it can be rational, it could be irrational, it could be a decimal, fraction, whole number, negative number. It doesn't matter. It could be anything. The only thing it can't be is our imaginary I. So it could be everything except for I. Our range, again, is going to keep going on forever, so it will hit every single range value in existence. So I would say y is also an element of the reals. Now, we could write these also in interval notation. If you wanted to do that, it would be negative infinity to positive infinity, because it uses everything. So negative infinity to positive infinity is how we would say that if we wanted interval notation. For some people, yeah. Negative infinity to positive infinity, that's if you wanted to write it as interval notation. All right, number 6, let's put this one into our calculator. It's a lot easier to figure these things out when you have a graph of it as opposed to an equation. So to get your absolute value, you push math, you go over to num, which is that first one, and then abs, that's your absolute value. So math over to num, first one, abs, and then it's x plus 2, right? So then if we look at our graph, there's our graph. We have a nice little V shape for absolute value. So I'm going to draw a little picture quickly. Boop. So is this a function? Yes, it is a function. Is a function. Is it one-to-one? No, because it would fail that horizontal line test. Is it onto? Nope, because it wouldn't use these negatives down here ever. So it's just a function. Domain. This one's going to keep going on forever. So your x's would be an element of the reals, or if you prefer negative infinity to positive infinity, it could be everything for that one. Our range, though, can we use everything for our y's? No, we already said that. We said it wasn't onto, so it's not going to be everything for your y's. So if we take a look, our lowest y value here is 0, and then it's everything above it, so y is greater than or equal to 0. If you wanted to do that in interval notation, it would be bracket 0 to infinity. Whenever I say that, I always think to myself, to infinity and beyond. All right, 3 more. Almost done. So number 7, are we a function? Nope. Not a function. Nope. Can't be one-to-one if it's not even a function. First step is it has to be a function in order for that to be true. Well, you always have to start with that because you always have to first check. Yeah. All right, so this one, our domain, it goes from 0 to 3. I like to use interval notation for these ones. You could do set builder. And then what's our lowest range value? -3, and it goes to +3. -3 to 3. Mm-hmm. 8. Are we a function? Nope. Not a function. Domain. Again, I would want to use interval for this. What's our lowest x value? -3, and it stops at +3. How about for our range? -3, +3. And there we go. Now, not all circles work out that way. If they're centered around the origin, they would. All circles are perfect. They all have the same thing. Nope, it's not. All right, last one. Type that in your calculator. Look at the graph of it. I don't know. Take a look at it. Graph it. You didn't even look at it. You can't tell me it's not a function. Yeah? Maybe you should think again in your head. You should get a graph that looks like this. So does it pass the vertical line test? Oh, yeah, it does. So this is a function. Is it 1 to 1? Yes. It levels off, kind of. It looks like it does, but it actually still keeps increasing ever so slightly, so no range value is actually repeated. But is it onto? No, it's never going to be negative. So our domain would be x is less than or equal to 3 if you're doing set builder. Interval would be -∞ to 3. Range, y is greater than or equal to 0. 0 is the lowest it gets. It's just going to be above your x-axis there. So 0 to +∞ if you wanted interval notation for that one.